Hello everyone, this is Ms. Page. In this lesson, we are going to learn how to solve quadratic inequalities without graphing. In a previous lesson, we have learned how to determine the intervals where a function is positive or negative. This has a direct connection to solving inequalities of any type, quadratic or higher degree. So we've learned that if a function is positive, that's talking about where the y values are positive or negative, and for the y-axis, positive values are above our x-axis and negative values are below. So when a function is above, such as here and here, our x-axis, that means that our y's are positive or greater than 0. When our function is below the x-axis, that means our y values are negative or less than 0. And these are inequalities. So when we're solving a quadratic inequality, what we have instead of a y on the left-hand side is an expression, a polynomial expression that represents a related function, y equals that expression. And so we're doing basically the same thing. So when we figure out, remember, that where a function is positive, then we're looking at the x's that correspond to the positive values. And that would be here for our inequality and our corresponding interval notation. And when we are looking at where a function is negative, these negative y's correspond to the x's in the middle. And that's this compound inequality here and its related interval. All right, so here we are now looking at the connection that I was just discussing with some algebra shown. So here we have an inequality that is being solved, polynomial inequality that's quadratic because x squared is our highest power of x. One is greater than 0 and the other is less than 0. One of the things we're going to have to do is figure out the zeros of the related function y equals x squared minus 4. And so we can use our factoring skills to figure out where our zeros are, which would be at -2 and +2, and that's graphed here on this number line. This number line actually represents our x-axis of the related function, and these are the zeros. And then the related function, y equals our x squared minus 4, which is also shown over here, that would have to open upwards because our a value is positive. And so here we're looking at the related function on this number line. And some people like this strategy. These pluses represent where the function is positive or above the x-axis. This minus represents where the function is negative or below the x-axis. The solutions, you have to remember, correspond to the portions on the number line, which is your x-axis. So this is where the function is positive at x is less than -2 or greater than +2. And in the middle here, this is where our function or inequality is negative, which is between -2 and +2. All right, so we're going to look at a few problems and dissect them from the point to where we've already determined the zeros and the positive and negative intervals before we get into the whole process. So here we're looking at how to correctly interpret the number line that we create. So here's the inequality that we're solving. This quadratic represents a function, y equals, which would be a parabola. That parabola has zeros of -1 and +3. And that's what we're seeing here on our number line. And the parabola opens up because a, again, is positive. So we're looking at this situation. We need to know, do we want to focus on where the function is positive above, remember this number line is like our x-axis, above the x-axis, or where it is negative below the x-axis, and that has to do with our inequality symbol. So this is our greater than 0 notation, and so that means greater than 0 would be numbers that are positive, or y's that are positive. And so we're looking at where the function is positive, which would be here and here. And then the solution would be the x intervals that correspond to those points with those y values. And so we're looking at x less than -1 or x greater than 3, which in interval notation would be from -infinity to -1 and from 3 to positive infinity, as shown here. Let's take a look at this one right here. So this is the inequality that we are solving, and the 2x squared plus 7x plus 5 again represents a quadratic function, or as a related quadratic function, and its zeros from its factored form can be determined to be -2.5 and -1. When you do your number line, which again is your related x-axis, make sure that the smaller number, of course, is to the left, just like it would be on a number line. So -2.5 is to the left of -1. Again, a is positive, in this case a 2, so our parabola again opens up like so. But then again, we need to pay attention to the inequality to determine, well, which intervals are we focused on? Intervals where the function is positive or intervals where the function is negative. So here we're looking at the inequality. That's our less than 0 notation. So less than 0 numbers are negative, which means we're looking for where the related function would be negative or the y's would be negative, which would be this section here. Our solution then are the x's that correspond to those y's, which would be the x's in the middle here. And that's this inequality from -2.5 to -1. All right, and one more. Let's take a look at this one. So this one, here's the original inequality that we're solving. One option, you do not have to do this, and I'll talk about the other option in a moment, but the way this one is solved is that we look at multiplying this inequality times -1. What you have to remember is that this will change the inequality symbol. So here it's a greater than in the original problem, so now it becomes a less than, and all of the signs on the numbers change. 0 is still a 0, since anything times 0 is 0. Now we have to realize, so this is our function that we're now looking at, y equals 3x squared minus 8x plus 4. And here's its factored form, so we can determine its zeros are 2/3 and 2. In this, our a is positive, so again, it opens up. But what we're doing here now is focusing, we have to realize that this is the inequality we're solving. So it's not this we're paying attention to anymore. It's our less than 0, which means that we're dealing with the negative section. And our solution then becomes the values between between 2/3 and 2. Now some people don't want to multiply by -1, and that's fine. The difference would be when you do your factored form, so now we have greater than 0, you can factor out a -1 if you want to, or you can just factor with the -3 if you want to. I think it's easier if you factor with the GCF of -1 being factored out first, so then you get this, and now this stays a greater than 0. But what you have to realize, you'll get the same zeros. So here's our x-axis, here's our zeros of 2/3 and 2, which come from our factors of 3x minus 2 and x minus 2. But now we're using this as our related function, and a is negative, which means our parabola opens down, like so. And the inequality we're using is greater than 0, which means now we're looking for where our function is positive, and that would be above our x-axis. And so that would correspond to the x's between 2/3 and 2. Notice that's exactly the same solution, which it should be if this is a valid way to solve it. So some people prefer to just work with the negative and then their parabola opens down. Other people prefer to multiply by -1 and then their parabola opens up. And you can use either one when we're doing a full problem. All right. So this is the procedure that I have basically just been discussing. We're going to make sure that our inequality is in standard form first. If it's not, we are going to find the roots, which remember is a synonym for zeros. We're going to create a number line that represents our x-axis and includes those roots or zeros. Then we can either test our intervals or we can graph a sketch of the parabola to determine where our number line, which sections will be positive and which will be negative. And interpreting that, do we want the negative or the positive situation, and write our solution using proper notation. All right, here's our first full problem. So this is the inequality we're going to solve. So the first thing we're going to do is we are going to find our zeros of the related function. So we're looking at the factored form of our function, and that would be x plus 6 times x minus 4. So either x plus 6 equals 0 or x minus 4 equals 0 using the zero product property. So we get two zeros, -6 and +4. Now I'm going to make that number line, which represents the related x-axis for the function, and I want to make sure the smaller number is on the left, so -6 is to the left of +4. And now what I'm going to look at is the related function, which would be y equals x squared plus 2x minus 4, or sorry, minus 24. So our a value is positive, a +1 in this case, so our parabola opens up. So here's what we have so far. Now I need to know, do I need to determine my positive or negative intervals? And that has to do here with our inequality. So that symbol right there is our greater than 0. Numbers greater than 0 are positive, which means we want positive y's. And that would be this section here and this section here. So this corresponds to this portion of our x-axis. And these points correspond to those x values. So then our solution. So notice here, up here it says that we want to write our solution as an inequality and as an interval. Make sure you know which one is which. So your inequality notation would be with your less than and greater than symbols. So you have two intervals here. So here this would be, these numbers are to the left of -6, so that means they're smaller. So x is less than -6, or these numbers are to the right of 4, so that means they're greater than 4. So x greater than 4 is that second section. And then your interval notation, remember intervals are always written from least to greatest. So that means left to right on a number line. So -infinity to -6. In union with from 4 to +infinity, like so. All right, let's take a look at another one. So here's the inequality we're going to solve. So again, first thing I'm going to do is find the roots or zeros of the related function. So I am going to factor that trinomial. So I have a 2x and an x. And let's see, looks like we want +4 and +3. That'll give us 8 + 3 for 11x in the middle. So either 2x + 3 equals 0 or x + 4 equals 0. And Here we'd subtract the 3 first and then divide by 2, so that gives us -3/2. And this one we'd subtract 4, which gives us -4. Now -3/2 is -1.5. And that's important because in our next step we're going to make that number line that represents the related x-axis. And we want to make sure we understand -4 is the smaller value, and so it has to be to the left. Then I'm going to look at the related function, which would be y equals 2x squared plus 11x plus 12. And its a value is 2, which means that it opens up. Like so. Now I have to figure out, do I want the sections where the function is positive or the one where the function is negative? And that has to do with this inequality. So this is less than 0. Numbers less than 0 is negatives. That means we want the section where y's are negative, which would be this section. And that corresponds to the x's that are between -4 and -1. So remember that when you write this type of inequality, this is a compound inequality that we're talking about the x's between these two numbers. So it's -4 is less than x, and x is less than -1.5. Read from the x's perspective, x is then greater than -4. So if -4 is less than x, x is greater than -4. And that makes sense because these numbers in the middle are to the right of -4, so they have to be greater than -4. And they're to the left of -1.5, so they have to be less than -1.5. Notice both inequalities need to be less than inequalities for that inequality to make sense. And then our interval notation. This is only one interval, and it goes from the -4 to the -1.5, non-inclusive, meaning that technically those endpoints are not included in the solution because that's where the function equals 0, not where it's negative. All right, we have one more example, I think, to take a look at here. Here it is. All right, so here is the inequality we're going to solve. So with this one, there are two ways really that we could solve this one. I'm going to do this using the strategy where we do not multiply by -1 as my first strategy, okay? And so what I'm going to look at is finding the zeros of y equals my related function, -3x squared plus 10x minus 8. So I'm going to factor out a -1 because I like to factor better with a positive a value, and that will change the signs of my numbers. And then I will factor the trinomial, which gives me 3x and x. And let's see, what are we going to want here? I think a -4 and a -2. That'll give me a -6 plus -4, which is -10. So here what we know is -1 can't be 0, so we ignore that one. 3x minus 4 could be 0, or x minus 2 could be 0. On this first one, we would add 4 first, and then divide by 3, so we get 4/3, which is 1 1/3. And then here we'd add 2. So in my next step, when I go to make my number line, which represents the related x-axis, I have to realize 1 1/3 would be to the left of 2, since 1 1/3 is smaller than 2. Now I'm going to look at my function. So the function the related function here is y equals -3x squared plus 10x minus 8. And this parabola will open down because a is negative. So it does this. So now I need to know, do I want to know where my function is positive or where it's negative? And again, that has to do with this inequality here. So here I'm looking at this being a less than 0, which means that I'm looking for where my y's are negative. My y's are negative this section and this section, which are below my x-axis. So they correspond to the x's here and the x's there. So my inequality notation for my solution, these would be two separate intervals. So these are to the left of 1 1/3, so that's less, so x is less than 1 1/3, or these are to the right of 2, so x is greater than 2. And my interval notations would correspond, this would be from negative infinity to 1 1/3 in union with 2 to infinity. Negative infinity to 1. And if you write 4/3 here instead of 1 1/3, that would be fine also. This would be union, and then from 2 to infinity, like so. All right, let's take a look at a practice problem. So pause your video here and give this problem a try. Let's take a look at the result. So here, factoring the trinomial, we can find the related roots or zeros of the related function, which would be positive 6 and negative 1. This is our number line that represents the x-axis. This notation here has just done little pluses where the function is positive and a minus where the function is negative. The a value of this related function here would be positive 1, so it does open up. So you can see the graph there. And if you want, all you really have to do is the graph. If you want to do little pluses and minuses, if you like that strategy, you can use that too. Here we are looking for where 0 is, or where the function rather is greater than 0, so where the function is positive, which would be here and here, which correspond to these x's, less than negative 1 or greater than 6. Let's try another one. Pause your video here. All right, let's take a look at this result. Now this practice problem, which has a negative a value, so you may have solved it a different way. This one shows the strategy of first multiplying the inequality by negative 1, shown here, and that changes the signs of all three of the numbers, and it changes the inequality symbol from greater to less than. Then factoring gives us the zeros of negative 9/2 and negative 2. In this case then, we are now going to, on our number line, graph y equals the positive 2 function, which means it does open up, and the sections are determined by the less than 0, which means the negative sections, or section rather, which would be here, which corresponds to the x's between negative 4 and negative 4.5 and negative 2. If you didn't multiply by negative 1, your zeros are exactly the same. So you have your negative 9/2, which is negative 4.5, and your negative 2. And your function then is y equals the negative 2, which means that it opens down since a is negative. But now you're looking at this inequality greater than 0, which means in this graph you want to know where the function is positive, which means above the x-axis. And then that would correspond, notice, to exactly the same interval of x values. So either way is fine. All right, that ends this lesson. So have a great day.